Hello everyone, welcome to the final episode, or the final part for this episode. In this episode, we're going to be finishing off by making local character commands where we can access commands directly off of a particular character that we want to run some logic for. So this is going to require us using another format for our commands. We don't have to change much of anything. All we have to do is check for one little symbol when we execute a command. So let's go ahead and take a look at what that'll look like. So for this example, I want to change move character and create a separate function that I can run directly off of Stella to move her to this position. So instead of saying move character Stella, what I'm going to do is say Stella.move and then move her to the position that I want. And I'll just do I'll move her to the other side. So we'll go 0 and then we'll go just 1 and then speed 0.5. We'll change this to 0.5. I want to see the difference between these two functions. So we'll go ahead and wait for that to complete, and then we'll wait for this one to complete. But of course, we would have to go into our database and then add Stella.move. For that to work, we would wind up having to do something like this, and this is not what we're going to do, but we would have to do something like Stella.move. And of course, that's not going to work since we will never really know what the character names are. So we need to search for a period, or whatever type of symbol you're going to use for this, to identify what we'll call a subcommand. And a subcommand will essentially take the name of what precedes it as the name of some kind of new database. And it'll look in that database for a command called this. So it would then look in a database called Stella and look for move. But when we're working with characters, I want this to route to a character instead of like anything else. So it'll look and see, hey, Stella's a character on the screen. Okay, so what can Stella do? Stella can move. So call move on Stella and move her to the position. That's basically what I want to do. So we're going to remove that and we're going to open up our command manager for a minute. Our command manager, first of all, when we execute a command, we just go ahead and try to get the command as is. Now we're going to need to change that. We're going to need to look for this subcommand identifier. And that subcommand identifier is just the period. So real quickly, let's go ahead and make a private constant character called a subcommand identifier. And this is going to equal just the period. So I want to check for that. I want to check and see if that exists. So inside of execute, let's first check if command name dot contains the subcommand identifier, then this is a subcommand. So let's go ahead and make a new function that will go ahead and execute that appropriately. So private coroutine wrapper execute sub command, and we'll take the string for the command name, and we'll also take a string, if I can ever type right, a string array for the arguments, just like we have above. So if we contain the subcommand, then we'll go ahead and return execute subcommand, and we'll pass in the command name and the arguments. Okay, so in order for us to execute a subcommand, we need to figure out what command it's a part of. Like, what is it that's supposed to be running this command? All of it is still going to be contained within the command manager, but now we're going to get into making some sub-databases. So instead of just having one database, we're actually going to have multiple databases that can be used in this command manager. So we're running everything right now out of our main database, and this is essentially the default database. Now, since we're going to be running subcommands, let's go ahead and make a new list of databases as well. This is going to actually be a dictionary with a string that maps a name to this sub-database, so that way we can identify the left-hand side of our command to the right-hand side command function call. So we're going to make this a private dictionary with a string and a command database. And this will be our sub databases. Doing this, when we create subdatabases and map them to specific names, Stella, first of all, is not going to map to any particular name. So if it doesn't match one of the subdatabases, we're just going to go ahead and look and see if it's a character. But this will allow us to do things like camera.setFOV or scene.change. This is just different ways you can do it and segregate your commands, if that is something you so choose to do. If not, you can avoid the sub-databases entirely and just go on ahead to work with character direct commands. But if you want to make use of this sub-database feature, which I think I will in the future, which is why I'm going to go ahead and include it here, then let's go ahead and make this dictionary. And now when we go to execute one of these commands, we need to first go ahead and split it into the different parts to identify the database name and the command to be run. So string parts equals command name dot split, and we're going to split it by the subcommand identifier. Now we can find the database name as the first part in here, but if we have multiple periods, I'm just going to assume that maybe that's something we can do. Then we'll go ahead and just accumulate all of the parts except for the last one. So if we have cam.current.setFOV, like I said, I'm not going to be using that, but I'm going to put it in here just in case anyone else wants to go down fancy lines like that, and maybe you might not be sure how to do it. So let's go ahead and get our database name, which we'll call the command from, and set this equal to all of the parts except for the last one, which will be the actual command name of the database. So we'll use string.join for this, and we're going to join everything by the subcommand identifier, and what we're going to do is we're going to use parts.take, and we're going to take everything except for, or up to, the parts.length minus 1. So everything except for the last part. And then the string subcommand name equals parts.last. So at this point, if we ran cam.current.setFOV, cam.current would be the database name, and setFOV would be the subcommand name, just as an idea there. So now all we need to do is just make sure that our database actually exists. So if subdatabases.contains key, and this will be the database name, if we have that, then let's go ahead and try to get the command from it. So delegate command equals subdatabases, and let's grab the database name dot get command, just like we did up above, but use the subcommand name. Perfect. So now let's just check and see if the command is not equal to null. So if we have a command, then return start process, and we're going to start this command name. It's going to be the name of the process. We're going to pass in the actual command to be run and the arguments to be run on that command. If our command is null, then we're going to want to just debug and log a message for ourselves. We'll log an error message and say that no command called subcommand name was found in subdatabase database name. And then we will go ahead and return null. Okay, so if we have a command and we have a subdatabase that we've defined, we'll go ahead and execute the command in there if it exists. If not, then if we've made it down here, then we should try to run this as a character command. So if you're not going to use subdatabases, ignore all that and just go ahead and run the character command. So we need to see if we actually have a character by this name. So if character manager.instance. Well, we could use get character. Let's actually make another command called has character. that we can use just to check if we have a character in the scene. We'll do this just to eliminate a slight bit of overhead and give ourselves, it's not much, but we'll just go ahead and add this in here. So public character has character, and we're going to take a string for the character name that we want to find, and it's just going to be one line, and we'll check and see if characters contains key, the character name to lower. Ooh, I'm sorry, not a character type, a Boolean. We're just trying to see if it exists. And so if we have the character, which is going to be the database name, essentially, then we can go ahead and try to run a command. Now, let's skip this for right now, and let's go ahead and say what we'll do if none of that is true. We'll go ahead and log another message saying that we had no database of what we were trying to call. So debug.log error, and we'll say no sub database called database name exists. And then command subcommand name could not be run. And if that happens, again, we'll return null. Now, if we do have the character, then we'll go ahead and create one more function that will execute this command on the character type. We're going to call this execute character command, and we're going to take a string for the command name, as well as the string array for the arguments. Now what this is going to do is it is going to reach into the code that's supplied by our database extensions. We're not going to run any kind of switch statements in here to find what command we should execute on the characters. We're going to do it just like we did for the database extension. In fact, we're going to add commands to the sub-databases just like we do here, and then just call the commands and execute whatever code has been assigned to those commands from the database extensions. So the database extension is actually not going to know what character this command is being called on. Even though we know which one it is inside of the command manager, the actual code that's being run is not going to know what character that is because it's not within the actual parameters of the functions being called. All we have are strings, string arrays, and we can use enumerators, but the only stuff we're taking in is strings. So we can't pass in a character. So we're going to have to get the character within that function that's being called, which means our database is going to need to have the character added into the parameters and use that as the first item in the array, just like we did for this move character function. We see the character name is the first object in the data array, and we get the character from that. So in our command manager, if we know that we have that character, we need to inject that character name into the parameters and then send those arguments and that command to be executed by whatever code was assigned via the database extension. That is a big mouthful. Basically, we just need to tell it what character name it needs to look for. Okay, so what we'll do is we'll go ahead and make a new list of arguments. That way we can inject the character name. So list string new args equals new list string. And now we're just going to insert that name. So new args dot insert 0, and we're going to input the database name, which is actually the character name. If you wanted that to be clear, we can say string character name equals database name, and then just replace database name with character name. That way we know what we're dealing with. And then args will equal new args dot to array. So we'll go ahead and add that character into the array and return execute character command with the sub command name and the arguments. So as for what we're going to do in this execute character command, We can execute different functions depending on the character type that we're working with, such as sprite and live 2D and 3D model. Again, if you're only using one, then you don't need to worry about having different databases for your different characters because they'll all be using the same stuff. But with me using 3 different types, and for anyone else who's using multiple types for any reason, you need to figure out what type of character it is that you want to execute this command on, and then load the database for that particular character type. So that way we can get the appropriate functions and have the right functionality for whatever character it is that we're trying to run. So first of all, let's get a variable that we can cache the command from that character's type-specific database into. Let's just make a delegate command and set that to null right now. And now let's go ahead and try to get the databases. Now for the characters, they're going to have 4 different databases. We've got 3 different character types, so we'll have 3 separate databases, but then we'll also have a database that they all share as the base character type. So let's just make 4 strings to represent what these database names will be. We'll make it a public constant string database characters base, and this will equal just characters. We'll duplicate that 3 times and change this to sprite, and then say characters sprite. We'll change this to live 2D, and change this to live 2D as well, and the same thing for model 3D. So when we look for the database for the particular character type, we're going to look for it based off this constant value. The first thing we want to do is we want to assume that this function is available to all characters. So we'll try to get the command database that all characters share. Command database, we'll just call it db, equals subdatabases, and we'll try to find the characters base with all the functions that will be available to all character types. And now let's just check if db.hasCommand, and let's look for the command name. If that's true, command equals db.getCommand, and this will be the command name. We're going to try to get the command name, and then return start process with the command name, passing in the command, and passing in the arguments. And we'll go ahead and start that process. If the command that we're using for this character is not found within the functions available to all characters, then we need to look for character-specific commands. So we need to grab the configuration for whatever character it is that we're running this on. That way we can get the character type. So let's go ahead and get our character config data and say character config data equals character manager dot instance dot get character config, and we're going to get it from args0 because that first element that we injected is the name of the character. So we're going to find the character, get their configuration, and find out what type they are. And then we can switch based off of their type. So character config data dot character type, and try to run some logic. Try to find their command data set. Let's first look if we have the sprite character, and this can also be the sprite sheet character. If we have this character as a sprite sheet, then we'll say db equals subdatabases, and instead of the base database, we're going to look for the sprite database. And then command equals db.getCommand, and we'll go ahead and break. Actually, we'll be running that on all 3 of these. We'll be getting the command no matter what, so we'll actually run command outside of this loop. So all we need to do is get the subdatabase. And then next one is the live 2D character, and we'll say db equals subdatabases characters live 2D break, and then lastly, the model 3D. There we go. So we go ahead and get the database, and then we try to get the command. So let's see. If we do have a command, if command is not equal to null, then let's try to start the process. Return start process by the command name, the command, and the arguments. And if that did not happen, we know something went wrong, and we can go ahead and say debug.log error, and we'll just say command manager was unable to execute command name on character that was args0. Then we'll say the character name or command may be invalid. And then return null. Okay, so this should work. But we need a way to actually create these sub-databases. And each extension to our database is going to have to create its own sub-database where necessary. So that means we need to add a function that they can access from the command manager. So we'll just make a public function down here that will return and create a command database. And we'll call this create sub database. And then have a string for the name of the database that we want to create. We'll say name equals name.toLower, so it's case insensitive. And if subdatabases.tryGetValue, let's see if we actually have it before we try to create it. And out command database db. So if we already have it, then let's log a warning, debug.log warning, and say a database by the name of, we'll call this name, already exists. Then return db. So we're not going to create it, but we'll still return it. Then command database, new database. If we have reached here, that means we didn't have one, so we can go ahead and create it. So we'll create a new command databases, or new database, and then say subdatabases dot add, and we'll go ahead and add that new database and return the new database. So again, this will allow our database extensions to create subdatabases for further segregated commands. And in this case, in particular, our characters will be able to assign different commands to the different character types by creating a subdatabase for each of those character types. That will limit what functions are available to other character types. So for sprite characters, when we search the database, we can't call setBlendShape because it doesn't exist, but it will be there for model characters. So in here, inside of our extension for these characters, now we can go ahead and create this new database. Let's start by adding the commands that are available to all the characters. And let's go ahead and create the database. So command database base commands equals our command manager dot instance dot create subdatabase by the name, and I think we can, yeah, we'll just go ahead and call the command manager dot database characters base. And now we're free to add commands in here. So let's start by making a show command that can, no, I said we were going to do a move command. So let's make a move command that can run on our Stella. And we've already got move character here, so we can just reuse that, but now make it available for Stella specifically. So base commands dot add command, and we're going to add move. Move is going to be the command, and it's going to be a new func with a string array of a type IEnumerator. And we'll do move character. Great, so we're going to pass in the name of Stella, and then use that same move character command. Which means now move character Stella and Stella.move should do the same thing. Now, it didn't work for me, so I debugged it and saw that my command name is actually capitalized, and that's not going to match, so has command is actually not case insensitive. So let's just do to lower. We need to make sure that case insensitivity follows through all of these commands. And now let's see how this works. So first one is the global. There we go. Second one is the local command called off of Stella. Perfect. So now I can go ahead and add show and hide using two different functions, show and hide, just for these base characters. Where show will try to get the character. It'll do nothing if the character's not existing. It'll get the immediate boolean, try to get the parameters, and then go ahead and set the character to visible, or show and add a termination process. The same thing for hide. It'll do just the same thing, but now we're working on local character level. So in this case, I can't specify multiple character names because it's not going to recognize them. Well, I could, but it's not going to do anything with those parameters. And now, after we move, we can hide her, and then reveal her again, and then go on to move the second time. So she moves, then she hides, reveals, and now she's moving again. Now I can add another command for each character called setPriority, which will then run this function to grab the character, and then try to get the priority, and go ahead and apply that to the character. So before we move, I'm going to make Stella set her priority to the front of the screen, wait a second, and then make Raylene set her priority to the front of the screen. And funnily enough, nothing happens, for good reason. When we insert the name of the character into the arguments, I don't have anything to insert in front of it, because this argument array is being created empty. And instead, we need to specify the old arguments for this new list, and then insert it to the very front, so that way we preserve all of the arguments. There we go, and now we can see setPriority working. I can also add a base command called sort, which will allow me to sort all characters that I mention on the screen through the character manager. And then go ahead and provide the order to sort the characters that are displaying on the screen, starting with Stella first. That way, even though they were created in opposite order, they'll display with Stella on top. There we go. That works. Now, for this next function, I'm going to set the color of the characters. And I'd like to make a way to grab a color value, such as color.red, color.green, from a string name. Currently, there's no inbuilt method to do that, but we can make our own. If we come into extensions and just add an extension for the color type, then we can go ahead and add this function for us. So we need to name this very specifically the class that we want to change, and then the extension or extension's name. So I've just pasted in this code from a previous project that I worked on, and all we need really is this function here, get color from name. We pass in a color name, and then we match it to any one of these values. By doing that, I can now create another command for the character called setColor, and then the setColor command, which will find the character. It'll cache a color name, a speed for the transition of the color, whether we want to immediately set it or not. Then we'll get the parameters. We'll try to get a color parameter as a string, and then if we specify a speed, we'll know that by the fact if we specify the speed identifier. If we have not specified speed, then let's try to see if it's an immediate transition. If we have specified speed, we can assume it is not an immediate transition. And then we'll go ahead and try to get the color using that color extension that I just showed you. So we'll get the actual color value from the color name, and then go ahead and set the color on the character. Should work, right? Well, we could try this after sorting the characters in the right order by saying Stella.setColor, and then say red, so she should turn red. But instead what we get is an unrecognized color name, Stella. That's odd. First of all, that could be remedied if we just precede it by the color parameter identifier, tac_c, and she gets her color. But if we omit that parameter identifier, since this is the only parameter being passed in, we should just get red. But remember, when we're using a character command, it's automatically going to inject the name of the character in there. So that command is essentially looking like this. So we have Stella and Red. So it's trying to find, since we haven't identified a label for this, it's trying to find the first string that it can in the parameters, which is Stella, not Red. So we need to tell certain commands to ignore the character name. Now let's just make a way for us to, when we grab the parameters, since we've already got the character name, we can go ahead and just skip that name inside of the data array. So maybe what we can do is we can come into convert data to parameters, and then go to the command parameters and just add another parameter here. We say int starting index equals 0. And so instead of starting at I equals 0 every time, we'll start at the starting index, which can be changed. And then we'll go ahead and do the same thing for these variables. So starting index equals 0. And then we'll pass in the starting index, which means for our parameters here, we can then specify that the starting index is going to be 1 and not 0. So we will skip the character name. And that means if we go to run stella.setColorRed, it will work. The next thing we can do is add highlight and unhighlight commands to our characters. And for highlight, what we're going to do is grab the character, and then we'll try to see if it's an immediate effect or not. We'll try to get the parameter to see whether it is immediate. And then if it is, we'll highlight and set an immediate variable to true, which we've not created yet. If it's not, we'll just yield and wait for it to highlight. And of course, add the termination process to make it immediately do so. And the same thing goes for unhighlight. We'll do the same exact thing and just make sure we are unhighlighting. Now, as far as setting an immediate effect, what we can do is this. If we want to be able to instantly highlight and darken our characters, all we need to do is add a boolean to their data here. So we'll go ahead and say bool immediate equals false, and then go ahead and copy that, and make sure that's passed into our other parameters as well. And then we'll pass that into the main highlighting function. And that means we need to change it on our other character types. So if we do character sprite, then we can come down to highlight, which will now have an error because it's expecting bool immediate. And the only thing we need to do is just make this an immediate transition on every layer for the character. So let's check. If immediate, then let's go ahead and set layer dot set color instead of transition to whatever our display color is. Otherwise, we'll go ahead and transition the color. And we'll do the same thing for live 2D as well. We'll go ahead and take this in here and say if, first of all, we need to specify that we have a boolean called immediate. So if immediate, then we need to go through each renderer in this live 2D character and assign its color manually. So we could say for each var renderer in render controller dot renderers, then renderer dot color equals display color. If we are not doing an immediate color, then we'll go ahead and do what we were doing by go ahead and yielding for that coroutine. And for our model 3D character, we can do the same thing, adding immediate here, encapsulating this, and check if immediate. If we are, then we need to go ahead and apply the colors to all of our renderers. We currently don't have a function for that, so let's go ahead and make a private void apply, good lord, color to renderers. And we'll just take, this is not my typing day, we'll just take color C, and then go ahead and say renderer dot color equals C. And then for each var old renderer in old renderers, then or dot old image.color equals C. So if the effect is immediate, then apply the color to the renderers of our display color, else yield until we change to that color. By doing that, we can now get some instant or transitioning highlights and darkenings on our characters. So now I should be able to wait until they unhighlight, then the same with them highlighting, and then immediately unhighlight and immediately highlight. So there they go. They set in their positions and they highlight well. As you can see, I also created a function for set position rather than move. That way I can just immediately set them to a position without having to specify any sort of special parameters. And if you're curious, that's all it is right here. And in case I want to do that on many characters at once, I've also added a global function for highlight and unhighlight as well. And what highlight all does is it creates a list of characters. I can define whether it's immediate or not, and whether I want to do the exact opposite for any unspecified characters. And then we can add all the characters to the list to be highlighted that I have defined. So we go through the list of the data, which should have all the character names, and then we go and find the character if it exists and add it to the list. If we don't have any characters in the scene, then we do nothing. Now we try to get the parameters. We'll try to get the immediate parameter, and then we'll try to get another parameter which specifies O, or only. And this essentially means that we only have the specified characters highlighted, and all of the other ones, all the unspecified characters, will then be forced to unhighlight. Then we go through each character, and we try to highlight them, depending on whether we have specified immediate or not. If we are handling unspecified characters, then we loop through every character within all of the characters defined in our character manager array. This is not available to you, but all it is just a retrieval variable that goes in and gets all the values of the character's array or dictionary, since that dictionary is private. We then check if our characters list contains the character that we're checking for, and then if it does, we do nothing. Otherwise, we'll go ahead and add this as an unspecified character and perform the opposite action on them, which would be unhighlighting them. And then, if we are not immediate, then we go ahead and add a termination process, which will go ahead and highlight and unhighlight the characters as needed, and then wait until this entire process is finished. And we run through the same thing with unhighlight all, and just do it in reverse for unhighlighting the characters and waiting for them to unhighlight and handle any of those unspecified characters to make sure that they highlight instead. So now what I can do is I can unhighlight both Stella and Raylene, I can wait a second, and then highlight both of them again. Then I can reveal Guard in the center of the scene so we can see all of them, and then only highlight Stella, which, since I'm specifying only Stella to be highlighted, then Guard and Raylene should automatically unhighlight. And then do the exact opposite, where Stella is the only one unhighlighted, and Raylene and Guard 1 highlight. So they darken, and they highlight, there's the Guard, and now they're all dark, and now only Stella is darkened. Next, if I want to add a command that's only available to sprite characters, I can do so by creating a new subdatabase and giving it the name of that sprite character's database, since that's what the command manager will look for any type of sprite character. And then by adding a command called setSprite, I can then call this setSprite function, which will find the character. It'll have a cache for the layer, the sprite name, whether it's immediate or not, and the speed of the transition. We'll get the parameters, then we'll try to find the sprite, we'll try to get the layer, we'll try to get the specified speed. If we haven't specified a speed, we'll try to see if it's an immediate transition or not. And then we'll try to get the sprite based off of the sprite name that was passed in as a parameter. If there's no sprite, do nothing. If this is an immediate transition, all we do is use the character setSprite. Otherwise, we go ahead and add a termination action to set the sprite, and go ahead and yield for the transition to this current sprite. Which means I could go ahead and set her layer 0 sprite and her layer 1 sprite for Raylene, and we can see her transition her sprites. And then to see how this would work if I try to call it on some other character type, we're going to create Emily, who is a text character. And then we'll try to set her sprite to happy and make her say hi. And what we wind up with is Emily as the character saying hi. We created the text character, and then command set sprite does not exist in the database. Command Manager was unable to execute set sprite on Emily. So we can see that set sprite is not valid for Emily because of her character type, but it is valid for Raylene because of hers. So that is that. There are more commands to do, but honestly, at this point, I think everyone's pretty clear on how to implement these for your projects. You can go ahead and finish up and take care of those other commands, and we will go ahead and pick up in the next episode where we're going to move on from this, and we're going to focus on some other features of the visual novel. We're going to now move into layers and controlling the backgrounds and the foregrounds and the cinematic and everything, and then move on to the audio system and these individual systems to go ahead and finish up and polish off our visual novel. So, hope everyone enjoyed, and hope this was useful, and we may come back, I may come back and show like the other finished functions, depending on if that's what people want to see or not, but like I said, I'm pretty sure everyone's pretty straightforward here, everyone understands how to do this, how to implement those extensions, and set up all these commands. Pretty simple. So, I'm going to end this one off here, and I hope everyone had a good time. I'll see you guys in the next episode. Bye.